So, all right, here we go. Here's our first one. All right, this means nothing to us. This still is kind of a boring picture, but let's just look at it, okay? So this is saying this is a T distribution, okay, with the degrees of freedom of 14. They set their alpha at 0.05 on a two-tailed test, okay? They're saying the critical values and the rejection region is illustrated. Why isn't it drawing? Here's our critical values, okay? And it's marking off our rejection region. Okay, so now let me show you where they got that number from, okay? So try and remember this in your head, 2.145. They told us a degrees of freedom of 14, alpha 0.05, a two-tailed test. An alpha for a two-tailed test, 0.05, and degrees of freedom of 14, which is over here, remember? And there's that value, 2.145. They said a degrees of freedom of 14. Alpha level 0.05 for a two-tailed test. That's where we get this value, the 2.145. Okay. I'm just showing you where we got it. I'm going to come back to this real quick. Okay. So what this is, these are our critical values. Okay. Our critical value determines the rejection region. So when we do our statistics, when we do our number crunching, we're going to come up with a number. We're going to have like this T value, okay? And we're going to come up with a number. And let's just say that number came to 2.5. What we would do is take it and move it over here and find where is 2.5, okay? 2.5 maybe would be somewhere about right here. That value is in the rejection region. And when it is in the rejection region, we get to reject the null hypothesis. Let's say we got a T value of 1.47. Say we ran our numbers and we got a T of 1.47. I don't know exactly where it would be, but maybe somewhere about here, 1.47. That number is not in the rejection region. It's not in the rejection region because it's not, oops, it's not over beyond this one or beyond this one, right? It's not in the green part. Okay, it's in here. It's within the critical values. So in this example, we would say it is not significant. A 1.47 does not exceed the critical value. Okay, let's see real quick. Oh my gosh, all these emails coming through.
So 2.5 would be significant, you're saying?
That's right. You would have a significant result there.
Okay, statistically significant.
Um, my handwriting's not all that good. Let's see. I was going to try and write something here, but I don't know if I'm going to have enough room. Okay, let's see. So, and we're not, obviously we have not started the t-tests, okay? So we're gonna get a t-value, okay? So I'm just gonna write that. Let's see, or reject, reject the hoe. Okay, I always say that. I tell that in my other classes. I haven't, I didn't set it up the same way with you guys. Yeah, I like to call it the hoe. We reject the hoe when our p-value exceeds the critical value. Okay, you reject the hoe when our t-value, and we haven't done that yet. Okay, so that's a number we will find. These up here are t-values. Okay, I haven't taught you that yet. I believe this book says fail to reject. Let me see. Ooh, he says retain. Ugh. But that's okay. I'll talk about these words in just a minute, okay? He says retain. I don't necessarily like that, but that's okay. Oh, we retain the hoe when our t-value does not exceed. Oops, I'll fix that right now. Does not exceed the critical value. Okay, so in this instance, right here, we would have to retain, oops, we would have to retain the hoe, or retain the null hypothesis in this example, okay? If your t-value does not exceed, it does not go further this way or further this way, then your critical value, you have to retain the null hypothesis. In this example over here, where our t-value was like 2.5, we would get to reject the hoe, reject the null hypothesis. We always want to try, well, yeah, we want to try to reject the null hypothesis. When you get to reject the null hypothesis, that's when you get to say your study has found something. You found a significant result. You proved that, you know, your little Einstein videos work, or you proved that the vaccine works, okay? Retaining the null hypothesis is not a bad thing. You just don't get to reject it just yet, okay? And you know, maybe I was a little harsh when I said I don't like how he uses the word retain. We absolutely never, ever, ever say accept. I'm going to put a big red X. We never say, oops, if I could spell also, that would work. We never say we accept the null hypothesis, because that's almost like just admitting defeat. If we accept that there is no difference out there in the world between, you know, I don't know, IQ and little Einstein videos, then it's like there's no purpose in going forward in your research, that you just accept that the null hypothesis is true. Okay, we're not going to say that. So what we say is we either retain or this is acceptable also. And you'll hear different people, different teachers say this: fail to reject. Okay, so fail to reject or retain the null hypothesis is are both acceptable ways to say that you found or you have not found significant results. So the word, it's just kind of like a play on words. It gets really kind of, it's like splitting hairs. But think of it this way: if you were in a fight, or think about this, have you ever been in a fight and you're arguing and you're arguing and you're like convinced that you're right, and then in the middle of it you realize you're wrong? Don't you hate that, right? Like all of a sudden you realize, you're like, oh my God, maybe I didn't tell them, or I didn't say that, right? It was somebody else. Now, if if you're a good person, you would just flat out say, oh, I'm sorry, I'm wrong, right? But some people are a little stubborn and they just keep going, right? And they just keep fighting it, whether they're right or not. So they could sit there and say, you know what, I fail to reject your argument right now. Or I will retain your argument right now. And maybe you have to go back and gather more evidence or something. I don't know what you have to do, okay? But fail to reject or retain is a lot different than, okay, I accept your argument, right? Or I accept the null hypothesis. Right now, I'm just going to retain him. I'm going to keep the null hypothesis around. I'm going to go back and try and change my study a little bit. I'm going to get more people. I'm going to show the videos longer or more times. I'm going to do something different with my study so that maybe I can find a significant value later. Okay, so retain, or right now I fail to reject the null hypothesis. Okay, let's see. I had a different thought and it already escaped my head. Maybe it'll pop in a minute. Okay. This is a lot. I'm going to erase all of this, if that's okay with you guys. Okay, as I start doing it before I even get feedback. Okay, I'm going to erase this and I'm going to pull up, or I'm going to make us a blank slide for us to practice on. Okay, so, or you know what, we'll just do it off to the side of here because sometimes it's kind of hard to go back and forth. Okay. Let me erase this stuff. Okay, so let's say I wanted you to find the critical values for degrees of freedom of 19. And for these purposes, we're always, sorry, I kind of started messing up right there. We're always just going to do an alpha equal to, that didn't work very well. We're just always going to do 0.05 and a two-tailed. Okay, so where would my critical values be? Ugh, that's a horrible one. For degrees of freedom of 19. Did I just mess you up? Does that make it bigger? For critical value, let's see, our critical value, we're always going to be right here, guys. Okay. And we want degrees of freedom of 19. Does somebody have that value?
It's 2.093.
That's exactly right. Okay. So our critical values, and sometimes if you just want to, you can just write them, 2.0, you'll see we'll do that in a little bit in the future. Critical values, and we always put plus or minus because we're doing two-tailed. two tails. We got to do our two tails, right? And we would have our negative 2.093 on this end, and we'd have our positive 2.093 on that end. Our critical values determine the rejection region, right? The rejection region is anything beyond, anything beyond the critical value. That would be our rejection region. I'm going to put RR. That does not look like an RR. Our rejection region on that end. And oops, let me minimize you guys. And our rejection region on this end. Okay. Now remember, or this was from last week, right? This 0.05 that we're picking here. Come on. Why is it, it's like freezing on me. This 0.05 that we're picking, remember in our fancy math, we can slide this little decimal over 2 times. And what we're doing is we're determining that extreme 5%. So that we can say we have a less than 5% chance or probability that our result came from chance or resulted in just sheer randomness. We want to reduce the likelihood that our results are occurring by chance, right? We want to know, we want to say with confidence that our results are because of whatever it is that we did, whether it was the vaccine or it was the little Einstein videos or it was some workout regimen. We want to say that our treatment is what caused that result and that it is not occurring just by chance. My dog will not go out of my door. Okay. Oh, I realize you guys can't see me. Okay. Oh my God, there he goes. Okay. So what this means, right, is that we're trying to say that we have, you could say a 95% confidence level that it did not just occur by chance. Okay. Now, when we make a decision, okay, and that's what we're going to have to do at the end of our statistics tests, okay, we're always going to come down to, we're going to have our value, we're going to have our t-value, and we're going to have to make a decision. And so if anybody you ever get accused of never making a decision, you can say, yes, I do. In statistics, I have to make a decision. Okay, so you have some evidence there. You're going to have to make a decision at the end of our test. And that decision is whether we're going to reject the null hypothesis or we're going to retain it. Okay, and it's going to be based on our critical values and whether that t-value landed in the rejection region. Okay. This will also come together a little bit better once we start doing our t-tests and we start really getting real numbers and then really testing them. Okay. Now, when we come to that point, and we're having to make a decision. of either to reject the hoe or retain the hoe, okay? There are 2 times that we might be wrong. Okay, there are 2 times or 2 possibilities or 2 opportunities for us to make an error. There's going to be 2 times when we're right. Okay. So if you retain the hoe and the null hypothesis was in fact true, then you've made a good decision. Now, what that means, right? They're saying, so when he's right, if you want to think of it that way, when the null hypothesis is correct, that there is no difference, and you say, okay, I'm going to keep him around for a little bit because I found no difference, then you've made the correct decision. When you reject him and he's false, right? He's false, he's wrong. When the null hypothesis is wrong and you're like, I'm rejecting you because you're wrong, then you've made the correct decision. Okay. The type 1 error, and I realize I haven't put these up here yet, is when the null hypothesis is true, but you're rejecting him. You're making an error there. Okay. You're rejecting him. You're saying, I found a difference, but in fact, no difference exists. You're saying, I'm right. Oh, this vaccine, I found significant results. It's going to work. But out in the real world, it doesn't work. There is no difference. Okay. What you're getting with this one is what we call a false positive. You're saying you have a difference, but there's really not one. Okay. A type 2 error is you're rejecting it, or I'm sorry, sorry, erase that. You're retaining it. You're saying, okay, null hypothesis, I'm going to keep you around. I did not find any results, but he in fact is wrong. He's not. There really is a difference. And so this one is a false negative. Can you imagine if we had had a false negative with the vaccines, which is what some people are out there worried about? They're worried that Pfizer or who, you know, these big companies are pushing this and saying, yes, yes, this will work, this will work. And a lot of people are having doubts. They're saying, what if it doesn't really work? Right? They're afraid of a type 2 error. They're afraid that those big companies are making a type 2 error. No, oh, that was wrong. That was totally wrong. They're afraid people are making a false positive. Can you imagine? They're afraid the big companies are claiming that they have a result and they don't. Can you imagine if a company was spending all this money and trying to come up with some cancer treatment, and their drug was doing okay, but they ran the numbers and it said, nope, you don't have any results. But what if in fact it really was working? And so then they throw away their medication and they just threw away something that could have actually saved, you know, all these people from cancer. That's a better false negative. I messed that one up. So a false positive, a false negative, girls know false positive and false negative quite well. If you've ever had a friend or some female in your family that has thought they were pregnant and they weren't, okay, that's a false positive, right? They get a positive result, or they think they're pregnant and they're in fact not, okay? A false negative, that can be bad, right? They take the test, the P-test, the pregnancy test, and it says, nah, girl, you're good. You know, no, there's nothing here. And when in fact you actually are pregnant, that would be a false negative. That would be a bad one, okay? There's a lot of like kind of, I don't know if it's debate, it's not debate, but maybe like just philosophizing, talking about false positive and false negatives, which one's worse. So maybe it is kind of a debate. However, you know, a false positive, while it can be bad, at least people are doing something about it. They might think that they have a result when in fact they don't. You know, that one would be a bad one too, in terms of maybe these vaccines and stuff. We wouldn't want them to have a false positive, right? But really, a lot of people say that the false negative is worse, because people fail to act when they should. Imagine if you went to get a CT scan, they were looking for cancer. If you got a false positive, now that would be really bad, right? I understand that. That would be horrible. It'd be horrible to learn the news or someone tell you you have cancer. As soon as that happens, you're going to go to other doctors. You're going to start seeking treatment, right? And maybe at that point, that's when they say, no, wait, hold on. Those results were wrong. You don't have cancer. Man, it would be horrible, but great news, right? You know, it would be horrible that they put you through that and that you experienced that yes, that would be horrible. But man, that would be a call for a celebration at that point, right? Because you don't have cancer. Now imagine a false negative. You go get a CT scan and they're like, no, you're good. You're good to go. And then you don't seek treatment. You don't act. And all the while you really do have cancer, and it's now getting worse and worse and worse. And so that when you go back to the doctor because you still just don't feel well, they say, oh my gosh, you have stage 4 cancer. And they look back at those results and they go, oh my gosh, it was here. We just didn't pick up on it. That they say is worse, right? So anyways, that's just a little bit, maybe too much thinking about false positives, false negatives, and type 1 and type 2. All you guys need to know is when we do statistics, can we be wrong? Yes, absolutely. We can be wrong. We are getting samples. We're trying to make guesses about the population, and we for sure can be wrong. However, we are going to try and do things that minimize whether we are wrong or not. We are going to try and find extreme values that say it is very unlikely that you just found this result by chance. We really feel like your drug works, or your therapy works, or your little Einstein videos work. The alpha is the probability of committing a type 1 error. So when we're going down here and we're trying to say at the 5%, but really when you're doing a two-tailed, you're way over here in the 0.25%, okay, that you have a very minimal chance of saying you found a result when in fact it's not really there, okay? We have to have confidence in our numbers, in our statistics, and in the process of doing studies and research. There's a lot of thought that goes into it. There's a lot of numbers, okay? So when researchers come out and say, we have found a significant result, we now know that a lot has gone into it. okay? And we are going to learn our very first steps for doing this, okay? Our very first chance and time to do this. We're supposed to do it next week, okay? So we'll start t-tests next week. Tomorrow is a holiday. Did y'all know that? It's Cesar Chavez Day. So you don't have any classes, you don't have anything like that tomorrow, okay? I will put these videos up, I promise. I'm going to try and keep it down because we're at about an hour here, and my computer seems to really not do well when it goes too far over an hour for the video. Does anyone have any questions over this stuff?
Sorry, what was the 5% again?
Yeah, remember when, let's see, I'm just going to put up a new slide over here. Insert new slide, and we'll go with blank. Okay. Remember when we when we have our distribution, remember we're going to try and separate off this extreme 5%, okay? So that 0.05, we slide it over, right, and we get 5%.
Okay.
When we do a two-tailed, though, what's happening is they're dividing up the 5% on this end and on this end, okay? And that's what this was showing right here. If you notice that, the 0.025 and the 0.025, if you slid that over 1, 2, you get 2.5% here and the 2.5% on this end, okay? And that's why we're doing that. If we went with a 0.01, right, our alpha was equal to 0.01, we'd actually be finding the extreme 1%. Okay. And I think, yeah, just maybe to tie it back to something more visual, more tangible, where is Einstein on this? Remember that? He's very far out there. He's not very common. It's not very likely that we have an Einstein walking around. So we know that getting a value way out here in our rejection region is very unlikely. It's not probable. Does that make sense? Does that, yeah. Okay. Yeah, so we're looking for those extreme values, those really unlikely events that can happen way out in the tails, okay? My drawings are horrible. Does that help? Do you have another question?
No, that makes sense. So the 5% is just the extremes, where kind of like the outlier of the data.
Yeah, and so in the Z, or in the normal table, because remember the normal distribution, it never changed. It just is set in stone, okay? So when we were looking at the normal distribution, it just, there were just so many things about it that are just exact. And those values, the Z values for the extreme 5% was 1.96, okay? I just know that, but you can go look at the T table and find that, okay? Or not the T, the Z table. In the T, that really smart guy said, well, what if we have different sample sizes, right? What if we have different sizes? We don't have millions of people. So he came up with a distribution where those critical values are going to change depending on the sample size. And we know that that's dependent on the sample size because of degrees of freedom. And this was from last week. Remember, degrees of freedom is equal to n-1. So whatever your sample size is, And that's how over here, remember, if we have a really small sample of say 2, that would give us a degrees of freedom of 1. We have these values that are really big here. He's saying if you have a degrees of freedom of 1, you better have a really big value and you better be way out in the tails, because the 5%, that extreme 5%, changes or becomes more difficult because you only have 2 people in your study. Now, if we look down here, right, we have more people in our study. So our degrees of freedom, say we had 20 people in our study, our degrees of freedom is 19. Now look at our values. They're not nearly as big. This one was 12.71. This one is only 2.093 because we have more people in our sample. So to find that 5% has now moved in a little bit. It's making it a little bit easier to get that extreme score. Again, this, you know, sometimes it just takes reading it over and over and over again. It just takes maybe me saying it over and over and over again, you know, for it to just kind of, I don't know, whenever that aha moment will be, right? Yeah, sometimes it, and in class, you know, it's fun. I love it when we're sitting in class and all of a sudden I can just see that light bulb go off and it just clicks. And someone is just like, it's all made sense now, you know, and I'm like, I get goosebumps because I'm like, yes, you know, it just, as we go on, if, you know, whoever, if we don't understand it right now, as we go on and the more practice and the more we talk about it, I think it'll start to make sense. And if it doesn't, and it never does, that's okay. That's a-okay. If you know just how to fill in these numbers and number crunch and get the result and write down what you're supposed to write down, that's fine too. Okay. You know, not everybody just kind of understands that this kind of theoretical side of statistics. Okay. So any other questions? No, we're doing okay. All right. So I don't think I'll get on tomorrow. I don't think I'm technically supposed to if it's a holiday. Okay. I think you guys are supposed to go and enjoy Cesar Chavez Day and take a break. I will get these videos up. I promise you, I promise you. And next week we'll start with hopefully tying it together more, okay, with our t-tests. Okay, I promise I'll get everything graded too. I'm missing on that too. I'll get that done. Oh, did I see someone raise a hand? No, maybe.
I gave you a thumbs up when you said you weren't doing class tomorrow.
Okay, cool, Cody. Thank you.
You guys have a great day.
You too. Christy, you were going to say something. I thought. Okay. All right. Well, maybe, so try, are you there? On my screen, you're kind of sticking.
Who, me?
Yeah, Christy, now I can hear you. Go ahead.
Okay. Yeah, I have a question. I had like a trouble to turn in the Z-score homework that we were assigned.
Okay.
And I was just making sure that you were able to receive it or no?
That's a good question. I don't know. I'm going to write it down right now on a piece of paper that I have, and I'm going to go check. And Christy, I'm going to get grades put in. So obviously, if you see a grade, you know I got it. If you don't see a grade, and I'm going to, why I wrote your name down is just so I can remember. I will email you if I can't find it. Okay. And so I'll send an email just to say, hey, can you try and send it again? Okay.
Okay.
Okay, perfect. Okay.
Oh.
All right, guys. Well, I will see you next week then. Okay. Okay. Bye, guys.